It's incredibly easy to just take the digital world for granted.
Yeah, totally. We do it all the time.
Right. You open up your browser, you type a question, you hit enter, and bam, instantly the entire universe of human knowledge is just right there, sitting on your screen. But, I mean, imagine if tomorrow you woke up and the internet simply stopped understanding your native language.
Which sounds like science fiction, I know, but it is a very real threat we're looking at today.
Exactly. So, welcome to this deep dive. Today we have a very specific mission. We're looking at a truly fascinating, almost forensic set of blueprints and diagnostic slides based on MetaNet research.
And our entire focus for this one is on one very specific subject, which is the Italian language in the digital age.
It is a remarkable set of sources, and the stakes outlined in these documents, they go far beyond just, fixing a buggy translation app on your phone.
Oh, absolutely. We are talking about the foundational infrastructure of communication here.
Right. The core theme across all this research is a pretty stark warning. They argue that the digital presence of a language is now a strict prerequisite for its cultural survival.
Which is a heavy statement.
Hmm.
And the researchers actually draw a direct historical line back to the 15th century print revolution to make their case.
Yeah, that part was fascinating because when the printing press came along, it standardized orthography, it locked in grammar, and it enabled this massive explosion of scientific ideas across Europe.
But there was a really brutal consequence to that progress.
Right, because oral-only languages, the ones that couldn't make the jump to the printed page, like Dalmatian or Cornish, they faced total extinction. They literally couldn't adapt to the new medium.
And now, in the 21st century, the research argues we are facing the exact same evolutionary bottleneck with the digital revolution.
That historical parallel really grounds the whole thing because, the digital revolution globalizes commerce and information at the speed of light.
Exactly. So the mission we're unpacking today isn't some abstract academic exercise about preserving a language for a museum exhibit.
No, it's about actively bridging the multilingual divide in the modern era. The goal is to avoid the digital extinction of culturally vital languages.
Because if a language doesn't have the underlying digital infrastructure to keep up with next-generation AI, it basically risks becoming practically invisible and eventually culturally irrelevant to the next generation.
Okay, let's unpack this. Because if digital survival is so vital, the immediate question that pops to mind is the path of least resistance.
Right, the easy ways out.
Exactly. Like, why not just let everyone speak English online? Or, if we want to be fair to everyone's heritage, why not just hire human translators to localize everything important?
If we connect this to the bigger picture, both of those seemingly easy fixes crash into massive economic and cultural walls. Let's look at the sheer scale of the translation and localization market in Europe right now.
That's big, right?
It is massive. The researchers estimate its annual value at a staggering 8.4 billion euros. And that is just the broader commercial market.
Wow. 8.4 billion.
Yeah, and if you look purely internally, the EU institutions spend roughly 1 billion euros a year simply to maintain their own internal multilingual policy.
Wait, 1 billion euros just to keep the internal paperwork and the committee meetings translated across all the member states? That is wild.
The financial weight is just immense. Human translation is a beautiful art, obviously, but it is fundamentally too slow and too costly for the sheer volume and speed of the modern digital economy.
Okay, so human translation doesn't scale.
Yeah.
But what about the other option? Why is defaulting to an English-only internet off the table?
Because it's entirely unacceptable from a cultural standpoint. It fundamentally disenfranchises millions of citizens who have a fundamental right to access information, government services, and commerce in their native tongue.
Think about it from the perspective of you, the listener. Think about the last time you bought something really complicated online.
Like a major appliance or something?
Yeah, exactly. Maybe you were navigating a checkout page or reading dense product reviews or trying to decipher some really confusing shipping and return policies.
It's stressful enough in your own language.
Right. So how much more stressful would that be if the entire site was in a language you only kind of knew?
That friction is incredibly real. And the research points out that 57% of EU internet users are currently actively purchasing goods and services in non-native languages.
That represents a massive amount of economic friction. People want to interact, they want to buy things, and they want to learn in the language they actually dream in.
Absolutely.
Right, so human translation is too slow and expensive to scale, and forcing an English-only internet is unfair and economically alienating. So let me push back a bit here.
Go for it.
If those two options are out, Isn't the absolute most obvious answer just building better translation machines? Like, just feed the whole internet into a supercomputer and let the algorithms figure it out.
Well, that has definitely been the dream of technologists for decades now. But to understand why that isn't a simple fix, why we can't just flip a switch, we have to look under the hood.
Look under the hood of what, exactly?
What the researchers call language technology, or LT, this is the underlying engine meant to bridge Europe's languages. And it actually relies on four main pillars.
Okay, what are they?
You have text analysis, speech interaction, machine translation, and information retrieval.
So in everyday terms, we are talking about grammar checkers, voice assistants like Siri or Alexa, automated cross-lingual processing, and next-generation web search.
Right, that covers the outputs we interact with. But the real challenge is the mechanism. It's how we actually teach machines to perform those tasks.
So how do they learn?
Historically, there are two opposing methodologies for teaching a machine to process language. First, you have rule-based systems. This approach is highly knowledge-driven.
Meaning humans are very involved in the setup.
Exactly. You have human linguists manually coding deep grammatical laws, syntax trees, and vast dictionaries directly into the system.
Which sounds very thorough.
It is highly accurate, and it allows developers to pinpoint and correct specific errors, but it is agonizingly slow and incredibly expensive to build from scratch.
Right. And on the other side of the spectrum, we have statistical learning.
Exactly the opposite approach. Statistical learning is purely data-driven. Instead of teaching the machine grammar rules, you just feed it millions and millions of already translated sentences.
So the machine derives mathematical patterns from that massive data set.
Yes. It's incredibly fast to train, and it adapts easily to new vocabulary. But it has a fatal flaw.
It's the flaw.
Because it doesn't actually understand the underlying rules of grammar, it often generates completely ungrammatical, nonsensical outputs when it encounters complex, novel sentences it hasn't mapped before.
You know, I like to think of this mechanically, almost like cooking. Imagine you're trying to program a robot to be a master chef.
Okay, I like this analogy.
Rule-based learning is like forcing the robot to strictly follow a very rigid, traditional 500-page family recipe book.
Right.
It's going to make an incredibly accurate, perfect dish every single time. But if you ask it to swap an ingredient, or you ask for a dish that isn't explicitly written in that book, the robot completely freezes up. It's totally inflexible.
That captures the limitation perfectly.
And then statistical learning is like, well, taking millions of ingredients and just throwing them into a giant blender.
Because the robot's sensors notice that flour, eggs, and sugar statistically appear together a lot in the kitchen.
Yes. It is super fast. It requires absolutely no recipe book. But sometimes it spits out a beautifully baked cake, and sometimes it serves you a plate of raw flour covered in scrambled eggs.
A very apt, if slightly chaotic, analogy, which is exactly why the ultimate goal in language technology right now is what researchers call the hybrid approach.
So, trying to get the best of both worlds.
Precisely. This aims to combine the deep, structural linguistic understanding of those rule-based systems with the rapid scalability and adaptability of statistical learning.
You want the chemistry of the recipe book paired with the speed of the blender.
Right.
So, if this hybrid approach is the holy grail of language tech, why isn't it deployed everywhere right now? Like, what's the holdup?
The holdup is that the hybrid approach relies heavily on the specific structural nature of the language you're trying to process. And that brings us directly to the unique, highly complex puzzle of the Italian language.
Which is an absolute powerhouse of a language. So it's
Okay.
not like we're talking about some niche isolated dialect with no data behind it.
Far from it. The demographic anchor for Italian is massive. The researchers note Italian has roughly 62 million native speakers worldwide.
That actually gives it the second highest native speaker base in the entire European Union.
Exactly. But from an algorithmic perspective, the sources suggest Italian basically acts like a wrench thrown directly into the gears of these statistical models.
Why is that? What makes Italian so mechanically difficult for a computer to process compared to, say, English?
It comes down to a few fundamental linguistic structures. First, Italian has what linguists call a rich morphology. It utilizes a highly complex inflectional system.
Meaning the words change shape a lot.
Yes. Nouns, adjectives, and verbs change heavily based on gender, number, tense, and mood.
So it's not like English, where you basically just have cat and cats or walk and walked. In Italian, the end of the word transforms constantly, depending on a whole matrix of conditions: who is talking to whom, about what and when.
That covers the morphological complexity, yeah.
Yeah.
But to compound the difficulty for a machine, Italian also employs a free word order.
Right, because English is very strict about its structure. Subject, then verb, then object. I eat the apple.
But in Italian, subject pronouns are often entirely omitted. You don't need to say I, because the verb ending already tells the listener who is doing the action.
Oh, wow.
Furthermore, subjects and objects frequently shift positions around the verb purely for stylistic emphasis.
Now wait, let me jump in here and look at this from a purely computational perspective. Because to me, as a non-linguist, isn't translation just a highly advanced word swap?
Not exactly.
But if the machine has a digital dictionary, why does it matter what order the words are in? Why does dropping a pronoun break a computer?
What's fascinating here is how those specific quirks utterly destroy basic statistical alignment models. Let's break down the actual mechanics of it.
Okay, let's do it.
If a statistical model is trained mostly on English data, it builds a probability matrix that expects a subject pronoun to exist. Let's use your example. I eat the apple. 4 distinct units of data.
Right.
Now let's look at the Italian equivalent. Mangio la mela. 3 units. The word mangio contains both the I and the eat baked into a single word.
Ah, I see. So the algorithm is like a set of interlocking gears. It's basically trying to mesh a 4-gear English sentence with a 3-gear Italian sentence.
Precisely the mechanical failure. The machine's grid searches for the word I, it fails to find a separate word for it in the Italian text, and it panics.
It just crashes.
It tries to align the English words with the Italian words in a one-to-one grid, and the entire alignment cascades into an error. It's looking for puzzle pieces that simply don't exist.
And the sources mention that regional bilingualism makes this even harder. Because standard Italian is one thing, but Italy has massive regional variations.
It does. The researchers highlight the Lombard language with 8.8 million speakers and Neapolitan with 7 million speakers.
That's a huge portion of the population.
And this heavy dialect influence fundamentally alters everyday spoken Italian. It changes the prosody, meaning the rhythm and intonation of the speech, as well as the phonetics, the actual sounds produced, and the core vocabulary.
So these systems have to adapt to these massive regional moving targets.
Exactly.
If the statistical alignment gears are grinding to a halt over missing pronouns and shifting vocabulary, where in the translation pipeline does the whole system actually crash? Is it right at the beginning or deeper in the process?
The blueprints map out this incredible anatomy of a translation pipeline, and it highlights exactly where the breakdown occurs. When you feed Italian text into a machine, it goes through distinct stages.
Oh,
First is pre-processing. This is basic character recognition, like detecting accents, for example, distinguishing between città with a grave accent meaning city and città written with an apostrophe.
which, to be fair, modern computers handle perfectly fine.
Yes, that hurdle is cleared. Then comes grammar analysis. The system identifies the verbs, the subjects, the basic sentence structure. Superficial spell checking works fairly well here.
Okay, so far so good.
But then it hits the third stage, which is semantic analysis. And this is where the system explicitly crashes.
Semantic analysis, meaning actually comprehending the deep meaning of the text, not just identifying the grammatical parts of speech.
That is the crucial distinction. Without deep semantic understanding, the machine cannot resolve ambiguity in Italian.
Right, think about words with multiple meanings.
Exactly. A machine might know what a word translates to literally, but without context, it doesn't know which version of the word to apply.
So how do you fix that?
To fix this, machines need massive open-source semantic databases, like IdleWordNet, for example, to provide that contextual map. Without them, the machine hits a wall. It knows the grammar, but it lacks the comprehension.
Because Italian breaks these semantic algorithms so severely, the researchers actually created a diagnostic matrix, right? Basically a digital readiness report card for the language.
They did, yes.
And if semantic analysis is crashing, I would guess Italian must be testing terribly across the board.
Actually, that assumption leads us right into a really dangerous illusion, because in some areas, it scores surprisingly high.
Really? Like what?
For instance, Italian scores between 4.5 and 6.0 out of a theoretical maximum in speech recognition. There is very robust commercial integration in that specific sector.
Which makes sense on a consumer level. Because if Siri or Alexa can understand my Italian perfectly right now, setting timers, playing music, turning off lights, why are the researchers sounding the alarm?
That's the trap.
Right. Why say the language is dangerously underdeveloped digitally if the voice tech works so well?
Because there is a vast mechanical difference between an interface correctly transcribing an acoustic sound and a machine actually comprehending underlying meaning.
Okay, that makes sense.
Yes, the voice recognition, the acoustic mapping is solid. But look at the rest of the diagnostic matrix. In text generation, Italian scores a 0. It is virtually
A
non-existent.
flat 0. Wow.
And in that crucial semantic analysis we just detailed, it scores weak, hovering between 2.5 and 3.5. It struggles profoundly with disambiguation and deep meaning.
So the machine can hear the words you're saying, but it can't really think with you. It can transcribe, but it can't reason.
That's a great way to put it.
So the real takeaway from the diagnostic is that Italian excels in superficial voice interfaces, but is dangerously underdeveloped in the deep semantic processing required for next-generation AI.
And the broader European leaderboard lays this out starkly. The researchers categorize digital language readiness into tiers. Tier 1 is English, which enjoys excellent, essentially 100% support across all these advanced language technologies.
Naturally.
Tier 2 consists of French, Spanish, and German, sitting comfortably at about 80% support.
And Italian is sitting down in Tier 3 at roughly 50% support, right alongside Dutch.
That is the reality. Now, below them, you do have Tier 4 and 5 languages like Basque, Bulgarian, Maltese, and Icelandic, which have fragmentary or weak support, hovering around 20%.
But being stuck in Tier 3 puts Italian in what the researchers call a precarious middle ground.
Yes, precarious because it relies so heavily on English as a crutch.
Right. The sources emphasize that cross-translation from Italian directly to other EU languages performs terribly. If you try to translate a complex Italian document directly to German, the machine often has to translate Italian to English first, and then translate that English output into German.
Which is incredibly inefficient.
You're bleeding nuance and cultural context at every single step of that process.
It acts as an algorithmic middleman. Italian benefits from past foundational funding, which built those decent voice interfaces and spell checkers a decade ago.
But it completely lacks a sustained, massive financial investment that is currently driving English, French, and German into the future of semantic AI.
Which brings us to the crux of the problem. If we want to pull Italian out of this Tier 3 trap and fix that semantic crash, we have to address the root causes holding the engineering back.
And according to the research, the roadblocks aren't just linguistic quirks anymore. They are structural, economic, and political deficits.
Exactly. The blueprints identify 3 core deficits that are starving Italian language technology. The first is the data deficit.
What does that entail?
We talked about statistical machine translation, and especially modern hybrid systems, needing data. They require massive bilingual data sets known as parallel corpora.
So, literally, millions of sentences translated side by side, perfectly aligned, so the machine can learn the patterns.
Yes. And outside of the Italian-English pairing, Italian severely lacks these parallel texts. The machine literally doesn't have the reading material it needs to map those complex morphological rules we discussed earlier.
So what's stopping the tech industry from just generating that data?
That leads to the second deficit, the industrial deficit. The Italian language technology market is highly fragmented.
Meaning there isn't one big player.
Right. Following pullbacks from major multinational corporations, the market is mostly driven by specialized SMEs.
Small and medium-sized enterprises.
And while those smaller companies are doing incredibly innovative, specialized work, they simply lack the sheer capital and server power to compete aggressively on global-based technologies against massive tech giants.
They are completely outgunned in terms of resources.
Exactly, and that leads directly to the third bottleneck, the policy deficit.
Which is sporadic government funding, basically.
The historical pattern is undeniable. Major national efforts, like the 1997 TAL project in Italy, occur in these dramatic boom and bust cycles.
So there is a sudden burst of funding, some foundational progress is made, and then the money just dries up for a decade.
Right. There is no sustained, long-term national research strategy for language infrastructure.
Here's where it gets really interesting, because the solution they propose to overcome these deficits, which they call the MetaNet Strategic Framework, fundamentally flips the whole paradigm.
It really does. They aren't framing this as just a neat software development project for tech companies.
They're framing it as civil engineering.
That mindset shift is critical. They are calling for the creation of a single, frictionless European digital market built on three overlapping pillars of action.
Okay, so what are these pillars actually proposing we do?
The first is metavision. This addresses the fragmented community. It is about building a cohesive, cross-disciplinary network of linguists, software engineers, and policymakers to actually align on a shared European strategy.
It's about getting all those disparate, small enterprises and researchers rowing in the exact same direction. Instead of 100 small companies working in silos, you create a unified front.
Exactly the goal. Then there is MetaShare. This directly targets that data deficit we mentioned.
Okay.
It's about creating a peer-to-peer network of open-source digital repositories. Instead of universities or companies hoarding their data, institutions would openly share their parallel corpora, their training data, and lexical databases like WordNet.
Because if everyone keeps their puzzle pieces private, the whole language suffers.
Right. And finally, there is meta-research. This targets the innovation gap. It's about funding frontier research to actually crack that hybrid approach for Italian.
Moving the technology beyond shallow statistical guessing and into deep semantic understanding.
The core insight driving all three of these pillars is profound. Language preservation in the 21st century is no longer about printing thick dictionaries or archiving old texts in a library.
No, it requires treating linguistic data and language technology as critical national infrastructure,
Exactly.
just like highways or power grids or municipal plumbing. If you want your society to function, communicate, and thrive, you don't just hope the roads build themselves, you fund, build, and maintain the infrastructure.
Right. To ensure the Italian language thrives in the Internet of tomorrow, the stakeholders must unite to fund and open source the ultimate digital bridge.
It is a massive, incredibly complex undertaking. But as we saw from the historical consequences of the print revolution, the alternative is a slow, quiet slide into cultural obsolescence in the digital sphere.
It really is.
So what does this all mean? We started this journey by looking at the historical thread of the printing press, wiping out oral languages that couldn't adapt to the page.
Yeah.
We explored the multi-billion-euro burden of trying to manually maintain multilingualism in Europe, and we dove deep into the mechanical difficulty of teaching a computer's statistical gears to interlock with Italian's rich morphology and invisible pronouns.
We covered a lot of ground.
We did. And we ended up realizing that language is fundamentally national digital infrastructure.
It represents a profound shift in how we view the words we speak every single day. And, the research leaves us with a critical, almost unsettling question to consider.
Oh, what's that?
If the digital presence of a language is indeed a strict prerequisite for its cultural survival, what happens to the way we think and express ourselves if our native language is forced to subtly adapt to the statistical limitations of English-dominated machines?
Wow, if the gears don't fit. Do we start changing our own language to make it easier for the algorithm?
This raises an important question for the future. Will our future languages shape the technology we build, or will the technology force our beautiful, highly complex languages to simplify just to survive the digital revolution?
That is a wild thought to end on, and something to definitely keep an eye on as AI continues to evolve. Thank you so much for joining us on this deep dive. Keep exploring, keep asking questions about the digital infrastructure around you, and we will catch you next time.